Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to draw tangents on the curve of a rate of reaction graph. You should then be able to use the slope of the tangent as a measure of the rate of reaction, and if you're a higher tier student, you should be able to calculate the gradient of a tangent as a measure of the rate of reaction at a specific point. In the last video, we started looking at rates of reaction. We saw that if we measure the quantity of product formed by a reaction over time, we get this graph. Remember that the slope of the graph gives us an idea of the rate of the reaction. Initially, the reaction is extremely fast. The reaction then slows down, and finally the reaction stops. Now, there's a problem here, and that is that the slope of the curve is constantly changing, and that tells us that the rate is also constantly changing. This makes it very difficult for us to get a clear idea of the rate of reaction at any specific point. In this video, we're going to look at how scientists solve this problem. Imagine that we wanted to measure the rate of the reaction at this point. Again, as you can see, the slope of the curve is changing. Scientists overcome this problem by drawing a straight line which just touches the curve at the point we're interested. This straight line is called a tangent. I'm showing you the tangent here. We can draw a tangent at any point on the curve, and the slope of the tangent gives us an idea of the rate of reaction. So here I'm drawing a tangent towards the start of the reaction. As you can see, this tangent has a steeper slope than the tangent later in the reaction. This tells us that the reaction is faster at the start than towards the end. Okay, if you're a foundation tier student, you can stop watching now, but higher tier students need to keep watching. As we saw, the slope of a tangent gives us an idea of the rate of a reaction at a given point. However, we can use the tangent to calculate the rate of reaction. Here's our line again, and this time I've put numbers on the x and y axes. I'm going to use a tangent to measure the rate of reaction at 30 seconds. So here's my tangent at 30 seconds. Now we use the tangent to construct a triangle like this. At this point, we need to find the lengths of the sides of the triangle. Reading from the y-axis, we can see that the vertical side stretches from 26 grams at the bottom to 40 grams at the top. This gives us a value of 14 grams for the y side of the triangle. Reading from the x-axis, we can see that the horizontal line stretches from 17 seconds on the left to 42 seconds on the right. This gives us a value of 25 seconds for the x side of the triangle. To calculate the rate of reaction, we now divide y by x. So 14 divided by 25 gives us a rate of 0.56 grams per second. Remember, you'll find plenty of questions on calculating the rate of a reaction using a tangent in my revision workbook, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to draw tangents on the curve of a rate of reaction graph. You should then be able to use the slope of the tangent as a measure of the rate of reaction, and if you're a higher tier student, you should be able to calculate the gradient of a tangent as a measure of the rate of reaction at a specific point.